Today I want to talk about the modifications that I made to the baler. When I bought the baler, it was a 3-point hitch type. The problem with this design is it won't turn in corners, so I converted it to a trail type. I designed this triangle with coupling and I mounted it on the original 3-point position. This hydraulic cylinder opens the gate when the bale's ready. When it came from the factory, the baler had its own hydraulic system and its own hydraulic pump. This was not very reliable in hot weather. The gate wouldn't open anymore. I removed the pump and now simply use the tractor hydraulics. This is how it looks like with the panels removed. That is the drive of the original hydraulic pump, which was removed. This is what the baler looks like when it's opened. You open it to release the bale when it's finished. Also, you can see the moisture meter that I have added. These are the contacts on the outside. This is the contact plate on the inside. This is the meter inside the cap that reads the moisture level. I will try to explain how the baler used when it came from the factory. When the bale forms in the chamber, the back door makes a gap. This makes a gap when the bale forms. It pulls on this lever, which works as a mousetrap, like this. There's all these rods, and when it's full enough, it pushes this up, and the twine winder falls, and it starts to wind, and it's finished. The problem is that it's not an accurate and not a reliable system, because there's a lot of play on all these components. So your bale density is not really the same all the time, and it malfunctions quite often. So I automated this. What I did is I placed a distance sensor here, and it measures the gap to this piece. That goes to a PLC, which is in this box. There are a few relays in this box for the controls. In the tractor cab I have a monitor, I will show it later, and I can set and read the width of the opening of the door. And when it reaches the set point, it sends a signal to this actuator, and it moves this lever, and it activates the twining process. That gives you a much more reliable function, and you can read the progress and you can set it. Also, I can read how much twining rope there is left, because when it came off the factory, that was always a guess. This is the housing of the twining rope, and I used part of the housing for the PLC and the relays. Now I will demonstrate in detail how the system works. I will use a lashing strap to simulate a bale being formed. When you hear the beep, it means the bale has reached its set point. Now let me show you some key features of the system. In this field you can set the opening of the gate. Bigger opening means heavier bale, smaller opening means lighter bale. This button is to automatically or manually start the twine winding. If you put it here in auto, on man, then this button activates the twine winding. In automatic mode it just uses this distance. This is the progress bar, and you can see what is the actual opening of the door. This is how much twine rope there is left, the total number of pressed bales, and this is the subtotal of the field, which you can reset. This is an optional relay that I will program later. Here you go to settings. Depending on which twine rope you use, you can alter this number, how many meters there is in one bale. Also, the second line, you can enter how much rope there is used in one bale. At this moment I use CSAL 330 and it is 990 meters per bale. One bale is 20.3 meters. These are settings of the actuator. You can adjust it, but it's okay like it is. And this is the delay of the new cycle, because the distance meter it measures the opening of the gate, but when you exit the bale it opens fully, so there has to be a period of time that it does not measure. The second line, that's the extra function that I will add later. These are settings necessary for good operations. This is the home button, you return to the home screen. Now I want to show you the drive side. So the power comes in at the PTO, there in the middle there's a gearbox, the power goes to the left of the machine. And this is the shaft where it comes. There's a brake bolt here. If anything gets stuck, this will break. Then it goes by chain all the way around to all the rolls that will form the bale. And also the chain goes through here. Here's a slip clutch and it goes to the pickup. And when the pickup gets stuck, the slip clutch will slip to protect it from breaking. So in short, that is the drive side of the baler. Thank you for watching. I hope you enjoyed my video. Please visit my channel again and don't forget to subscribe. Bye bye.